Hi, and welcome back to the digital job site. For this second of two parts that explain using SketchUp as a visual construction calculator. And the first part covered some basic multiplication, division, area, angle functions, and this second part I want to go through some volume things. And the teaser question I started off with at the digital job site blog post that has the title of Get Your Free Visual Construction Calculator at the digital job site. I posted a teaser question there about what's the volume of a cylinder that's 21.5 inches in diameter and 43 5/8 inches tall. So I'm going to answer that question or solve that problem quickly here by drawing a circle that has a radius of 10 inches and 10 3/4 inches will give us a circle with a diameter of 21.5 inches, which we can confirm with the dimension tool just by clicking here. It shows us that we have 21.5 inches in diameter. And as you might have guessed, I'm just going to drag this up 43 5/8 inches to give us our cylinder. I'm going to select this geometry and make it a group. Click the group, and this SketchUp gives us a volume in cubic inches. And I've downloaded a plugin which you can get the plugin link and the information on how to use it by going to the digital job site blog post entitled Mud Math. But I'm not going to go through the details there. I'm just going to take this group and select my volume plugin and say that I want to go to cubic feet for this. And that'll give us 9.06 cubic feet, which is the answer to the problem in the first place. So that's a pretty simple way of getting volume for a cylinder, and using SketchUp as a visual digital construction calculator works for any shape volume that you want to work with. This, if we had a cube, a block of any material, dirt, concrete, landscape, rock, whatever, it can be figured quickly. And let's just say we've got a 48 by 63 inch box that's 19 inches deep. You can just group this geometry and select it, and it tells us how many cubic inches. Again, if I use the plugin, it makes it really nice because it does the cubic feet. Let's go cubic yards this time and give us our volume of 1.231 cubic yards for that shape. And so that all works pretty good. Another thing, if you had for some reason to calculate the volume of a cone, let's say that cone was 27 inches, this would make a 52 inch diameter cone, and it's going to get a point at the center of this. And then let's say this cone was, I'm going to draw in the blue direction here so I get a cone. Once my line snaps to blue, let's say that needs to be 77 inches tall. So we can just do this real quick with this method. I'm just going to draw, this will be the angle of the cone, and if we select the follow me tool and this shape, that'll give us a cone. So if I take the cone and group it, then we can get the volume of the cone. And here again we're going to go into cubic feet. Okay. And I think I've got a little bit of a malfunction here. Okay, there's 33.63 cubic feet. A little bit of a glitch probably because, let's see if I've probably still got that web on the inside of this. It doesn't look like it. But that's one way of, that's kind of the process. There's some little glitch here that I'm overlooking, but by working past that glitch, you can get accurate volume measurements for different shapes. I talked about doing a tapered column. Let's make this one 18 inches square. And then let's make it 53 inches tall. And if we want the top of this, the bottom is, whatever I said, 19 inches square. If we want the top to be 18 inches square. If we want the top to be, let's say, 6 inches square, I've drawn it, the base 18 inches square, drawn the height we want, and to make this column tapered, I've selected the geometry of that top square, and then I'm going to use the scale tool, and by holding down the control key, it tapers this in evenly on all sides. So if we want an 18 inch at the base, 9 inches at the top, that's all I needed to do was to draw it up as a parallel sided column, and then use the scale tool with the control key to shrink the top down to the dimension I want. And by doing that, I can select this and group it to get a volume, which is 10,000 some odd cubic inches. If we use our volume plug-in, we can go to cubic feet and get our cubic feet. So if you're pouring some concrete bases for a post, maybe this will get wrapped with stone or something. It's pretty easy to figure out concrete volume for such things. And the other nice part about this is if we use the control key, if we were pouring 4 of these, we can just select those 4 columns, and I want to get the volume of those, and I may have to explode those, and volume parameters for 4 in selection, we want those in cubic yards. Okay, so each one is that many cubic yards. I think if I went back and exploded this group, copy that, multiply that one, and make all 3 of them a group. I get a combined volume using the volume tool. I can get this in cubic yards. It does the multiplication for me, or the addition of those. So there's a number of different ways. The point is, it's pretty simple to find the volume, change the volume, and calculate your total volume pretty easily. So I'm going to get rid of these objects and go over the last item I wanted to go over here, and that is to figure irregular area for something like a patio. So I'm just going to draw this box 12 feet by 12 feet, and let's see, delete this, get that out of the way. So let's say this is going to be a patio 12 feet by 12 feet, and we want to have, let's say we want to have a wavy edge on one side, and let's say that wave comes in 3 feet and splits at the center. Just drawing a couple guidelines here, and let's say we want to have a 27-inch wave in here. So I'm just going to take the arc tool, just throwing down some quick and easy dimensions here to get an idea of how to calculate these things. I'm going to grab this arc and move a copy of it over here rather than trying to draw 2 of them the same. Take the scale tool, I'm going to flip this around itself by going to -1, and then I can move it into place here and make it connect. Now if I move this, and this might be a frustration, if I move it and I drop it wrong and I try to move it again, it's going to make the geometry all wacky. So I either need to group this and move it, or move it accurately to right where I want it the first time, then it'll all behave. So if we take this geometry out of here, then we can get our area of this irregular patio. This would make kind of an ugly patio, but you get the idea of how to get these areas. You could put specific dimensions to this and find out the the patio area, and by default, if you were going to put some gravel down, you can raise this up, let's say 2 inches for gravel. And if we make this a group, we can get the volume of that group, again with the volume calculator, cubic yards of gravel to fill this, about 2/3 of a yard of gravel. And if we go back a couple of steps, we can do the same thing to figure out a 4-inch thick concrete patio. Same steps, you get the drill here. And get a group, get the volume, there's our cubic yards for this. And what that volume calculator does, it creates a copy of the geometry. The way I do this is I just get this, I take this value, the cubic yard value, and then hit the back key to get back just to my geometry. Another thing we could do is by copying this geometry, oops, I want to get it to slide over here, red direction. I'm going to offset this curve, let's say 24 inches. So we need a little pathway that had that shape. So I just copied the curve, used the offset tool to create my little sidewalk, and by adding a couple lines in there, all of a sudden I've got the area of a sidewalk, and we can do the same volume thing here by stretching this up any dimension we need to. So I think that if you tried to figure the area of something like this with a construction calculator, it would take you quite a while. And as I said in the beginning of this, the more complex the problem is, the simpler it is to solve with the visual digital construction calculator method. So you can find out all sorts of information by going through these steps. And I'll end this there. As I say at the end of the digital job site blog post, if there's viewer and subscriber interest, I can expand on using the visual construction calculator for quite a few things. You can do arc calculations, basically avoiding trig formulas and math just by letting SketchUp do all that work. You can use the same thing for counting tile, which I did cover in a Digitile blog post, but I can go quickly over some of those things and work out some of those details. So if there's viewer interest, I can do another job site post showing more visual construction calculator functions that you can do with SketchUp. But for now, I'll end this and wish you a Merry Christmas, and hope you'll stay and come back and visit the digital job site in the future. Thanks for watching.